Oh, what's up, guys? I'm back, and today I'll be doing my biggest video yet, and not because it's like I'm doing anything special, it's just I'm solving IPhO. Like, I'm actually doing a full solution on IPhO. I don't know if this has been a solution on YouTube before, but yeah, I guess I'll be the first. That's pretty cool. I did this problem during a study hall, in school, so yeah, I already did the problem. I looked at the solution, and yeah, I'm not gonna read it. I already did the problem. Yeah, so pause if you want to pause and don't pause type. So yeah, if you read it, we're gonna move on. So basically what we're gonna do here and the main trick of this problem is reversibility. What is that? It's instead of throwing the ball from the bottom up, we're gonna throw the ball from the top down. And basically how we're gonna do that we're gonna use a projectile envelope. Projectile envelope basically is it's this. It's the possible regions I can throw it to. So if I start here, what are the possible regions I can throw it to? The possible regions I can throw it to is anywhere inside this envelope, inside this hump. It can't go here or here because it's outside the envelope. That's what it represents. And it's given by the equation this. And you can watch my last video on how we derive this. We derive it two different ways. You should watch the first one if you're in a rush, but you should watch the second one. Yeah. If you're not in a rush, you should just watch both of them. No, I'm joking. Watch whatever you want, man. Don't tell people don't let people just tell you what you want, what you should do type stuff. Like just live on your own rules. So yeah, basically what we're gonna do is reversibility, and that means setting the coordinate plane above, right? So that we start in the center, and then we're gonna put this sphere under us. And that means the sphere is going to be given by the equation. It's not a sphere, it's a circle. Sorry. By this equation, r squared equals, yeah. Because the equation is normally this, where h and k, where h and k are the center. Yeah, h, k are the center, k are the center. But well, h is zero, right? Because and k is negative r because it's going down. So x squared equals to, not equals to, plus y squared minus 2yr equals 0 because at the end we're going to have an r squared term and that's going to cancel out with this r squared term. So x squared equals to negative y squared plus 2yr. We're going surprisingly fast. And that also means I make mistakes because this one's a negative. Yeah, rough. Anyway, we got this equation and basically what we're going to do is we want to put this envelope on top of the building, right? We want to put it on top of the building because we're on top of the building and we're going to put it on top of it so that we can say, like, let's say I take this trajectory, it's going to go like this. Let's say I take this trajectory, it's going like this. Take this trajectory, go like this. Yeah. We're going to put we're on top of the building, so our envelope starts at the top of the building and it's going to give us all the possible things. And this envelope isn't actually extended. I should extend this. You know what I'm saying? Like this. I should extend it. Yeah, they should make an extended version. But yeah, I hope you understand what I mean. Thrower is in the center, and all the possible outcomes are represented by this, and throws on the center. I hope I said that. Yeah. So we're basically putting throw in the center. Oh my God. Okay, yeah, I've said it like three different times. We're putting thrower in the center, and then we're gonna see like all the possible passes and take, and which one will minimize the velocity. Projectile envelope is really good for problems like that, and also angle minimizing as well. I should name this one velocity minimizing. That'd be really funny. I named the last one like height maxing or something like that. It got crazy views. Oh my God. I'm actually so happy. Thank you guys for dealing with my stupid stuff, my stupid activities every day, like solving this. Oh, there's a trick I want to use here. I shouldn't mention. Basically, what we're gonna do is we're gonna do substitution, and we're gonna say that h is VO squared all over 2g. We're gonna say a random variable h equals to VO squared over 2g. And the reason is if we just plug this in here, the algebra gets really, really long. And like it just fries me. Like I did this during a study hall. Like I think it was a frosh, but I was doing it and it took me like literally like it took me the entire block. to do the algebra, just the algebra. I figured out during like lunch or something like that. But yeah, it was really cooked. So like one, I can't go over 15 minutes because YouTube won't let me for some reason. I'm not a verified. I'm not cool like that. But yeah. And two, it's just like this trick is pretty neat, honestly. I'll explain what it physically means later. Okay. So basically what we've done is we made this new variable, h equals to VO squared all over 2g. Now 1 over 2h equals g over VO squared. And the reason why I did that was because this term, right? And now everything's in terms of h and x squared. And we know x squared is going to be this, so we're just going to plug it in. But first, I'm going to multiply both sides by the h, just because I don't like any like things in denominator when I'm plugging things in. So it's going to be plus y squared plus 2yr. Now, half this video is going to be computation. Oh my lord. Yeah, it's crazy. It's pretty long. But I mean, it is an IPhO problem. Did they get to work with each other on IPhO? Like, it's a team, right? It's like, I'd assume they work with each other. I'm not sure about the logistics about that. Yeah. 2r minus 4h y plus 4h squared equals 0. And now when they're tangent, so when the path is right, it means it'll be tangent, right? So like let's say I have the building here, the path will be if it's like this, right? There's obviously gonna be a short. It's gonna be a lesser velocity one, so eventually it has to be steeper than it, and eventually it's just gonna become tangent like this. So in order to find for tangency, we're gonna set the discriminant equal to 0. And the reason why we do this is because like let's say we take an equation where the discriminant does equal 0. Let's say this is an equation where the discriminant equals to 0. It looks like this. It like literally just bounces off at once and then it goes down once and then bounces up. We don't do the same thing here. We want to bounce first, I guess. But if you think about it like this, it bounce once and just go right over. And that's how we want to play this. So we're gonna do that. And discriminant equals b all over 4c. And if you don't know that, I don't think you should be watching this video, honestly. You should probably work on your mathematical. That's not even to be mean though. That it's not because like I'm being genuinely real with you. Like if you cannot do algebra, like like if you haven't passed it, like I think you should go back because physics Olympiad, like it does so much um math. Like physics and math are very like linked together, especially calculus because Newton Goat, he was like discovering that while he was discovering physics. He's so cool. He was like, yo, the math right now kind of sucks. I should make my own math. And he did. It was insane. He's still insane. Oh my God. Equals to 0. Um, yeah, 4r squared minus h plus h squared. Hold up. Something ain't right. I don't think I had this actually. Oh, wait. This b squared. Oh, it's just the first term. I need to do minus 4 I see. Sorry. And I'm talking about passing algebra. I think I passed that class actually. I did well in that class. My bad. Oh my God. It's okay to be a little stupid sometimes. Yeah. Minus 16h r equals to 0. And these cancel. Notice that. Okay, 16h r cancel. Cancel for r equals 16h. And now we have a definition for h. What is h? It is going to be 1/4 of r. Why does that matter? Basically, what we're doing, right? The main issue with getting over this thing, it's not just the height, right? It's not just the height velocity. It's also this velocity, this getting it over like this curvature. It's going to take some velocity. And basically what's happening here is instead of just thinking about them as two separate components, we're literally just gonna move the x. We're gonna move the x velocity like upward. We're gonna move it like this. We're gonna put it into the y direction problem. So we just have one problem. And well, now that's easy, right? You can just think about it as one dimension. We've condensed one dimension into two. I mean, two dimensions into one, and that's a lot easier to deal with. So here we go. V squ um v squared equals to square root 2gh. This comes from energy, by the way. I'll derive real quick. Basically, what's happening is 2gh, right? I mean, no, not 2gh, mgh, right? And basically, why we can write this equation is, remember, we don't have to account for the x direction anymore. It's all inside this h thing. So basically, what we're just gonna do is we're just gonna say, hey, this kinetic energy, it all turns into potential energy because it's gonna be at the top of the building eventually. We don't have to write another thing, another term, um, or we don't have to write anything else because there will be no more velocity at the end because all of it's going to be on the y direction. If we did not do this trick, if we didn't, then we would have to write it like this: mvo squared plus mgh. Because, and oh, sorry, equals plus 1/2 mv top squared. And basically, the reason is this. The reason for this is because there will be some type of velocity at the top of it. Like it'll like it's not going to be equal to zero at the top, which makes it really complicated. But if we put all the issues into y direction, then we don't have to make this complicated. So basically, how we're just going to do this is we're going to solve this energy equation. Yeah, by the way, the official solution does use energy. That's unfortunate because um it's like not accessible. Like I think it's kind of unfair, but it is a basic energy equation, honestly. It's not even that bad. 10, 20. Well, you're gonna have the height's gonna be 2r plus 1/4 r, and we're gonna have, oh wait, I don't know if we should do this actually. It's 2g, okay, I think. 2r, and we're gonna rewrite this. And basically what we're going to get is 9 all over 4r, and we're going to multiply this by 2g. So this is going to cancel, and we're going to get 9 all over 2gr square root is our velocity. Woohoo! Oh my god, I actually did it. Oh, first IPhO problem done. Let's go. And this is the solution, yes. If you want to look at the official solution, I think they might have it online. But I like this solution more because of this new method. I don't know if it's been covered before, but I didn't see it in Everest. So yeah, this is a long video for me. I did a lot of retakes, honestly. So yeah, smash like if you like, smash dislike if you didn't. I'm just copying Danny. I love Danny though. You guys should check him out. DAN. And is he dead? I don't even know. Oh, he's on Vetinad. Oh, I'm just yapping. All right, bye.